All right, so this next lesson is 7.2. This is over imaginary numbers with exponents, complex numbers a little bit later. But really, subtracting isn't it's not going to be anything. It's imaginary, but we do it the same way we've done other things with different variables. So we will get to that. So the first thing I want to make sure you realize, we're just going to do imaginary numbers squared. So I squared is how we're going to start. And the big thing is to realize that we're going to start squared. So if we have the 25 squared, there's two ways to take the square root of 25 is 5. You do that first, it's in parentheses, and then you square that, and that gives you 25. So that's the long way to do it. The short way is that a square root and a squared cancel each other. We talked about that before when we did solving with these. So really, you don't have to show all that work. I just know that that's 25. Same thing, number 2. I know that that's just 15. So then we get to number 3. We have the square root of negative. Again, we know that's got to just be -1. The squared and the square root each other. Well, why is that one important? Because now when we have number 4 says I squared is and the is because that's the thing we did over here with number 3. Remember, I just represents the square root of -1. The square root of -1 squared is -1, which means I squared is -1. Again, if you want to remember that, you can think of it just -1. Now, the other way to do it is just to memorize. Eventually, you'll probably get pretty good, or hopefully you'll memorize that I squared is always, you can substitute -1 in for that. I squared is always -1. Sitting okay because it's going to get a little bit more complicated. There's steps to it, but we start with that. That's the most important concept. That's what we're going to be working with in the next several lessons. You guys okay? Now, one thing, I threw this one in there, but really just the main reason I threw these 2 in here is to get you some practice or to get another review. If you have an exponent, remember there's a difference between having the 4i in parentheses and having it not in parentheses. In parentheses, that's both. It's 4 squared and I squared. Less steps, but 4 squared is 16. I squared is the same thing as 1. So if it's 16 squared, that's the same thing as 16 times -1, which is just -16. I will talk about this more a little bit later. I don't remember if it's today or tomorrow's lesson, but you will never have an exponent with your I, because if you ever have an exponent with your I, you can reduce that down. So just like I squared, you'll never have I squared because we can substitute a -1 in for that one. So you'll never have an exponent with I, because if you do, you can reduce down to either I or a -1 or something like that. We'll get into that in a second. Number 6, if there's no parentheses, that squared only goes to the I. So again, if you want to do 4 times -1, that is equal to -4. Now again, eventually you'll have to do that step once you get used to or good at or get a lot of practice with I squared is -1. You might just be able to skip to the -4. But again, there's going to be a couple different things we learn this lesson. There's going to be some more complicated things we get into, but the most important thing that's going to carry on in the next couple lessons is the fact that I squared is -1. So we need to make sure we have that. So far so good? Okay. Now, the next thing, in my opinion, is a little bit confusing at first, but it's really not that bad because you'll realize that it follows a pattern over and over and over again. And so I raised to any exponent, you're going to be able to reduce down, or you're going to be able to get it down to one of these first 4. So now I put a bunch of these on here. I had the 1st, 2nd, 3rd, 4th, 5th, 6th, 7th, 8th. I did this because I want you guys to kind of see what the pattern is. Now again, if this is confusing, hang with me, make sure you're paying attention, make sure you're doing the worksheet, because I think it'll click. Because in my opinion, it's not too bad. It just seems like there's kind of a lot going on. And again, you've never done this before. So this is one of those things that you did not do this in Algebra 1. So I is just I. Anything to the first power. 4 to the first is just 4. 5 to the first is just 5. 100 to the first, just 100. Anything to the first doesn't really need an exponent. We just talked about I squared is -1. Because again, it's the square root of 1 squared, which is -1. So we already know that one. This is where the fun starts. Now, eventually, I think you guys will probably memorize this, but in case you don't, this is how we figure out the answer. Do it. If I know that I to the first is I, and I squared is -1. If we know that, we can get anything else on this list. So, for instance, I know I to the third. I can break that down as I to the first times I squared. Because remember, when you multiply, you add your exponents. So if I have I to the third, that's the same thing as I to the first times I squared. That's I times I, which is I to the third. So far, so good. Does that make sense? Well, we know that I to the first is just I, and we know that I squared is -1, so I times -1 is -I. So I to the third is always going to be -I. Don't worry. So again, with a quick recap, I to the first is I to the second is -1, I to the third is -I. Now again, there's a couple other ways to look at that. And if you need to do that math, you're more than welcome to, but I think if I were you, I would memorize I to the third is -I. However you need to do that, if you need to do flashcards or repeat or write it down 100 times, I think it's going to be best to memorize that. Same thing, number 10, I to the fourth, again, different ways we can figure this out, but my favorite way is saying that is the same thing as I squared times I squared. Again, I squared is I times I. So that's I times I times I times I. That's 4 i's, I to the fourth. Well, we know I squared is -1. I know I squared is -1. -1 times -1 is +1. So I to the fourth is +1. That's all you have to memorize. Second, just to give you a heads up, those are your only options for your answers. When you have I to an exponent, that's it. It's either going to be I, -1, -I, or +1. Those are the only 4 options. So this is where the loop comes from. What about I to the fifth? Well, again, that'd be the same thing as if I took I to the fourth times I. I to the fourth, we know just 1 times. So that's the same thing as I to the first. That makes sense. That to show my work with this one, I started with saying I to the fourth, and I know that. So I like I to the fourth. That's going to be really key. That's just 1. So if we have I to the fourth, we know that's 1. We start over with our pattern. Goes to I. Same thing, I to the sixth, that is 4 times I squared. Well, again, we use that I to the fourth because that's 1 times I squared is 1. So I to the sixth is the same thing as I squared. And again, hopefully that makes sense because we take I to the fourth, and then we're left with I squared. So that's why, again, and I to the sixth is going to end up. You guys probably are ahead of me. You probably understand this, or you probably know where this is going. So I to the 13th is the same thing as I to the fourth times I to the third. I to the fourth is just 1. So really, I to the seventh is the same thing as I to the third. Because we take out 4 of them, it's just a 1, 3 left. So that I to the third was -I, so that's your answer for that one. And again, that's why I to the third and I to the seventh
And lastly, for this one, I to the 8th is I to the 4th times I to the 4th. That's 1 times 1, which is just 1. And again, that makes sense because if I to the 4th was 1, if I take out 4 of them, I have 4 left, so those two are going to be the same. So here's the pattern, and most of you guys hopefully see it by now. Your answers, actually, let me put a little bit more obvious here. Sorry, this will be worth it, I hope. So this is the pattern. I is the first, so these are I, -1, that should not, sorry, that dot maybe is going to throw people off. I usually don't have to be that specific with a dot. We have I, -1, -I, and 1. Those are your only 4 options. When you have I to an exponent, those are your only 4 answers. Those are the only 4 possibilities. I to the first gives you this. I to the second, to the third, to the fourth. Go back. 6, 7, the 8. To the 9th will be I. To the 10th will be -1, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. That loop goes. Every 4 is going to land on I to the 4th, and then you start that loop over. So this is the pattern that you're going to use, and then all the other ones you're going to be able to find. We just said I to the 9th. Obviously, the long way to do it. I to the 9th would be 1, 2, 3, 4, 5, 6, 7, 8. 2, 3, 4, 5, 6, 7, 8, 9, 10. I to the 10 to be -1. So that's the long way to do it. Obviously, if I give you one that's like I to the 176, that'd take a while to count those. So there is a shortcut. We'll talk about that in a second. But that's the pattern I want you to see. So again, I to the 9th is 1, 2, 4, 5, 6, 7, 8, 9. So I to the 9th is just I to the 10th. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. -1. And again, that pattern continues forever and ever and ever. Amen. Before I move on, I know that's confusing, so I want to make sure if anybody has any questions or little things they're confused about that they can ask, I want to open the floor to that. Because again, I understand it's a little bit confusing now, but I think it'll hopefully questions before we move on. This is always the hard part because I imagine there's probably that are bored to your mind because this is super easy, and there's some of you guys that completely have questions. Okay, so the biggest punchline to this is to remember that every 4th exponent is just 1. So that's the whole idea. When we did this math, we started with the 4th was 1. We started. We took out an I to the 4th, took out an I to the 4th, took out the 4th, so on and so forth. So the 4th is only 1. So 4, 8, 20, 24, 28, 32, so on and so forth. That's the key with all this math here. You're always going to start with that I to the 4th. So, when we have something like I, the easiest way to do it is realize that if your exponent is divisible by 4, it's going to be 1. So that's what I just was trying to stress, but that's probably a better way to say it. If your exponent is divisible by 4, your answer is going to be 1. So again, if it's 4, 8, 12, 20, if it's 40, if it's 60, if it's 80, if it's ever divisible by 4, you know it's just going to be 1. So if you know that, that's going to give you a starting point. So for instance, I to the 42nd is not divisible by 4. 40 is.
many more to get 42? So we have I to the 40 times I squared would be I to the 47, right? Can we all agree on that? The reason I picked 40 was because it's divisible by 4. So since it's divisible by 4, I know that's just going to be 1. If you need to count, you can. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, so on and so forth. Once you get to 39, 40, divisible by 4, so that was just going to be 1, so that's a wash. So I squared, well now we know, and if you need that chart, you can. I squared, we get 1. That's what we just talked about at the beginning of the lesson. I to the 47 down to -1. You know I'm at least on the right track, is because remember, there's multiple answers. 1, -I, or +1. That's it. That's a better way to remember that, is your answer is +1, or +I, or -I. Those are your only options. Don't think it's harder than it is. And I'm not trying to say that it's super easy. If you don't get it, you're dumb or anything yet. But I think some people make it way complicated. All it comes down to is I'm looking for a number as close to as divisible by 4. The way that you could have went past it, you could have used 44 and then worked your way backwards to -1. You can. I personally don't like that. I think it's more confusing. So I try to find a number that's smaller than the number we have that's divisible by 4. I try not to go over. To the 101 power. Seems pretty confusing, but remember, it's divisible by 4. That's as close to 101 as you can get. And if you're not sure, do trial and error in your calculator. I mean, you can first start out by doing 101 divided by 4 as a decimal, so we know it's at least not going to be I to the 4th for that one. So the one you're going to get is 4 times 25 is 100. So I can separate that. That is I to the 100, which means we need one more I left. To get 101, we start 100 I's. We chose that specifically because it's divisible by 4, and we have one I left. I to the 100, it just cancels. It's just 1. I to the 1st is just I, so your answer for this one is just I. I to the 101 reduces down to just I. I'm not saying that that's definitely the right answer. I mean, it is for this one. But when you get that answer, I'm not saying this is the best way to check your work, but again, it's got to either be positive I or negative I, +1 or -1. Those are your only 4 options. So last but not least, I know I've said this before, but in your answers, and this happens all the time, you should never have an exponent that is with your I. You should never have an I squared, or I to the 4th, or I to the 10th, or I to the 100. You should never have an exponent with your I. You can always reduce it down to either I or -I that don't have exponents, 1 or -1. So if you look at your answer, if there's ever an I squared or I to the 3rd in there, you did something wrong. That shows up not as much in this lesson as it does in the next couple lessons. So go ahead and do the next couple, 19, 20, 21, 22. Be careful with number 20. Again, when they're in parentheses, it's a little bit different. Again, I kind of just want to give you some extra practice with that exponent. But again, you're trying to find a number as close to 23 as you can that's divisible by 4, preferably less than 23. And that's going to be the ticket for that. If you're completely lost, let me know, because I'll come talk to you. Second. 19 and 20 up there, and that's how I would do them. 21 and 22 up in a second. That's the answer 21, 22. So real quick, one of the things I thought of when I was working through this, if you can't tell if something is divisible by 4 or what number is close that's divisible by 4, I would recommend doing this. So for 22, if you're not sure if that's divisible by 4, and you don't know what number that's close to that is divisible by 4, I would do this. 54 divided by 4, and because that's the exponent. 54 divided by 4 is 13.5. That's a decimal. So that one doesn't work. So then I'd go one lower. Instead of 53, well, 53 divided by 4, decimal, 13.25. So then I 52. 52 divided by 4 is 13. So that is the closest number that's divisible by 4 that you can get with 54. If you want to use that method, one of the good things I thought of is at most you only do 4 of those, because if it's not divisible, I mean, basically every fourth number is divisible by 4. So that even if you try to do it that way where you're not sure, so you just divide by 4 and you keep going down until you get one that doesn't give you a decimal, at most you'll have to try 4 of them. Okay. We only have about 5 minutes left, but that should be sufficient time. The next thing we're doing is adding and subtracting complex numbers. Matt, take a break. I'm just kidding. So complex numbers. Just FYI, complex numbers are numbers that have both a real number and an imaginary number with it. I think they also use the term complex numbers. I have to look into it when it's a number that has a normal number, a real number, and a irrational number like square root of 3. But for our purposes, complex numbers always have a real number and an imaginary number. So when we are adding and subtracting, so we will tomorrow, and it's going to be, some of you guys will really love it, some of you guys will not really like it. But that's a step harder, but adding and subtracting isn't too bad. The biggest thing is you cannot combine imaginary numbers with real numbers. It's not going to mix. You cannot do that. It's the same thing for number 1. When we combine these, it would be the same thing as if it was 3x plus 6 minus x. You do the same exact math. I can't combine 6 and 3x because once x is, so x's, you combine your x's, x would be 2x. So you'd have 2x plus 6. Same thing with the i's. It's no different. I mean, obviously, the variable means something different than just x. It means square root of negative 1. But for our purposes, 3 minus 1 is 2. 6 doesn't change. Now, I will say, I always put the real number first. But remember, when you do that, whatever with those numbers has to stay with those numbers. And what I mean by that is, this says positive 6. So when I switch their order, it's got to stay positive. The 2i is positive, so it also has to stay positive. Sign, that's where some. If we get one of those, we'll talk about it. Now, number 2, I threw an extra twist in there. Now, I promise on these problems, I'm not going to put anything more than I squared. If I have anything more than I squared, it's going to be a problem like we just did, not an adding and subtracting problem. The reason for that, we'll talk about that tomorrow. So I know I squared is negative 1. So before I do anything with this, I put in there, it's 2 times negative 1, which is negative 2. So then I rewrite this, the 7 didn't change, the 5i didn't change, and the 10i didn't change. And now I solve that problem. So always, if there's an I squared, I always change that to a negative 1, and I fix that, and I change that one before I do anything else. There's other ways to do it, but I like that way best. The same thing I just did. Real numbers first, so 7 minus 2 is positive 5. Negative 5, positive 5i, so that's your answer, 5 plus 5i. And that's what I mean. That's a complex number. The 5i. Since you're adding both of those, you don't have to change it. It's the same way with problems. However, I would still recommend your first step to drop the parentheses. Now, some of you guys aren't going to do this because it looks like it doesn't actually help you at all. But it's going to help you. It's going to help you with number 4. About that in a second. Oh, now simplify or we combine everything. So negative 16 plus 12 is negative 4. You need a calculator, you can. Negative 13 plus 6 is negative 7, I think. So you end up negative 4 minus 7. Next one, I will say, again, if you're going to switch the order, make sure you remember if that minus sign is with the 7, it stays with that 7. So if you put the 7 first, it's got to stay as a negative 7. And not that I recommend that, but I would, sometimes you have to change it to real numbers first. And again, I don't actually care what order you put it in. That's just more what's normal, what more people do or more math books do. And that's what I'm going to put my answers as. Okay. Number 4 is the hard one. And when I say hard, it's not really that bad. There's just one thing you have to remember. If you have subtraction, that subtraction needs to be distributed to both of those. So the thing that people miss with this all the time, and they say 2 minus 4 is negative 2, which is correct. But then they say 3 and 5 is 8. 5. That's not right. Instead, you have to, and it's so we have 2 plus 3i minus 4 minus 5i. Now you can go ahead and combine your like terms. Minus 5 is negative 2. You've got to leave it like that. Again, you can't combine your i's and your numbers. Now, again, this is a little bit of a side note, but I tried to make this make sense, and it didn't really help. But if you ever end up getting an answer like this, and I'm just making this up. So this is not on your notes. This is not from anything. You don't wonder why I got these numbers. I'm just making this up. If you got your answer as 4i minus 10, I would recommend putting that real number the same thing as 10 minus 4i. Make sure you know that. That's what I was talking about. That's not the same thing. If you're going to switch the order, that 10 has a minus sign, so it's got to stay with that minus sign. That 4 is positive, so it's got to stay as a positive. That's how you would change that order. So that's kind of what I was hinting at earlier. I tried to talk about it with number 3, but it didn't help a lot. Any questions on this?